Today's notes will cover in class 51, so you'll want to find that in your geometry spiral so that you can follow along. Our topic today is the second kind of special right triangle that we'll cover for Standard 12. So this is part 2. We're going to talk about what a 30, 60, 90 special right triangle is. So first off, this special right triangle is going to be a triangle that is half of an equilateral triangle. An equilateral triangle is something that we studied earlier in the school year. We've got a picture here to remind you, except this triangle is officially equiangular with 360-degree angles. If it was equilateral, we would have all three sides labeled in a way that matches, which we can do. So we can go ahead and label that these other two sides are equal to 10 because we know equal sides will always be across from equal angles. Now, if you imagine taking this triangle and splitting it in half, what we would have is this triangle over here. This corner would still be 60 degrees, but the top corner, if we split this in half, would turn out to be 30 degrees. This segment would come right down through the middle of this equilateral triangle, and it would end up bisecting this bottom side. So it would end up intersecting at the midpoint, which means this would be 5. Half of 10. Using our information from Standard 11, we could call this C. We have a right angle, so we could call this either A or B, and we could solve for this missing side using our Pythagorean theorem. And that would look like 10 squared is equal to 5 squared plus, I'm just going to call it B squared. A quick little simplification on both sides to get rid of those exponents is going to lead me to subtract 25 from both sides and then square root 75 to get my answer for B. Root 75 can be simplified, so whether you use factor trees or factor tables, it's going to turn out to be equal to 5 root 3 when it is simplified. And so that 5 root 3 is a description of the length of this side in that little half equilateral triangle. So what we're able to do is we're able to know that whenever we deal with half of an equilateral triangle, the angles will be 30, 60, and 90. That's always consistent. If we call our shortest side L like we're used to, there's going to be a relationship between this L and both of the other sides. When this side is 5, that side is 10. So this is going to turn out to be 2 times our L. And when this side is 5, that side is going to be 5 root 3. So it's going to be kind of hard to squeeze it in, but that's going to be our L multiplied by root 3. So the pattern that our sides will always follow will be L, L root 3, and then 2L if we're writing them from least to greatest. But when I label them, I work in a different order. I always identify my shortest side first across from the 30. Then I fill in the hypotenuse because I know that's going to have a 2, just like in our 45, 45, 90, there was a 2 there, but it was a root 2. And then across from the 60, my leftover side is going to be the one that has the root 3. If the triangle rotates around, we can follow that same pattern. The shortest side across from the 30 is L. Across from the 90 is going to be 2 times L. And then that leftover side across from the 60 will be L times root 3. Just like with our 45, 45, 90s, we're going to be dealing with radicals in these problems. So we've got a few foundational skill problems to take a look at to make sure we're ready to go. If I need to do 6 root 3 times root 3, I can now multiply those root 3's together. Root 9 is actually equal to 3, and so finally this problem simplifies to be 18. Moving to number 2, I'm going to multiply the radicals together again. But I get root 45, which does not simplify as nicely as root 9 did. This is where your factor tree or your factor table can come in. So if you're a factor table person, you might do 1 and 45 to start with. We can't divide by 2, but we can divide by 3. 15 doesn't square root, so we keep looking. Our next factor pair would be 5 and 9 does square root. So this root 45 part of the problem is going to become 3 root 5. The 9 becomes the 3 and the root 5 stays. We have this extra 5 out in front though, that's going to multiply by that simplified radical. So 15 root 5 will be our official simplified answer for that multiplication problem. You would get the same 3 root 5 answer if you did a factor tree instead of a factor table. Looking ahead at problem number 3, it looks like we're solving for x here. X is multiplied by root 3, so we're going to divide both sides by root 3 to isolate the x. Root 3 divided by root 3 is 1, so we can just write x on this side. The same thing happens over here, so x is equal to 7. When it comes to number 4, we have the same situation. We need to divide by root 3 to isolate the x, but we don't have a root available on this side to do the division. Now remember, we're not allowed to leave a root in the bottom of the fraction. We have 2 methods for dealing with this. One of them is to use that root that's stuck in the denominator to build a fraction that's equal to 1. Moving forward, our x will be all by itself on the left side. We multiply straight across, and we get a numerator of 12 root 3 and a denominator of root 9, but the square root of 9 is 3. Last but not least, we take a look at those rational numbers, the 12 and the 3. They can be divided, and so our final official simplified completely answer for this would be x is equal to 4 root 3. I'll show you the other method here with number 5. This is another situation where we would need to divide by root 3, but I can look ahead and see that that root 3 is going to get stuck. So if this multiplication by a fancy version of 1, called rationalizing the denominator, doesn't make sense to you, this is where we can take our equation and instead of dividing, we can choose to multiply both sides by root 3. And I'm going to use 2 different colors to show this just so that you can see what's happening. The green was the original equation, and I just multiplied both sides by root 3. That doesn't isolate the x, but it makes it a rational number attached to the x. So we're going to have regular 3x on this side equal to 11 root 3. And then we can come back in and we can do our division to isolate that x. Now in this case, our 11 and our 3 don't simplify like the 12 and the 3 did in the previous example. So the best way to write this answer is just to leave it as a fraction. X is equal to 11 root 3 over 3. One of these 2 methods is only required if division does not work, if you're not able to simplify the division on both sides. For example, 6, we're able to simplify the division because we have a root 6 that we can divide by a root 3. So this one is just going to end up being 5 root 2. All right. We are now going to use those ideas along with our new pattern to work on 30, 60, 90 special right triangles. So looking at our first 4 examples here, our goal is to solve for the missing sides, and we need to make sure that we're always giving our answer in simplified radical form, or exact simplified form is another way of saying that. I'm going to do these problems the same way we did the 45, 45, 90s. So I'm going to identify the shortest side first, always across from the 30-degree angle, that will be equal to L. Across from the 90 in the 30, 60, 90 is always 2 times L. And across from the 60 is always L times a root 3. We want to look at that and decide whether or not we know L. And in this case, we don't quite know it, but it's going to be easy to quickly find it. If we take this little equation we set up and we divide both sides by 2, that means L is equal to 3. Once you know your L, you always just take it and you plug it in everywhere the L belongs. So that means B is equal to 3 and A is equal to 3 root 3. Now, eventually a lot of that might happen in your head, but for right now I'm just going to show the work for all of them so that you can get used to the process. And the equation process will always work if you're not just able to look at it and know. All right, moving into example 2, I see a 60 and a 90, so I can fill that corner in with a 30. The shortest leg is always across from 30, equal to L. Across from the 90 is the hypotenuse, always equal to 2L, and then that third side that's left over is going to be equal to L root 3. This time, I know the L already, so that 5 is going to get plugged in everywhere we see an L. Up top, that means y is equal to 5 root 3. There's no extra simplifying possible for that. Down here, that means 2 times 5 equals x. We definitely can simplify that, and the official answer for x will be 10. Number 3, they start us off with the 30-degree angle, so we can fill in the 60 for ourselves in the other corner. Across from the 30 is always the shortest leg, equal to L. Across from the 90 is the hypotenuse, equal to 2L for these triangles. And then our third and final side is going to equal L root 3. This one doesn't tell me what L is equal to, but it gives me an equation that I can quickly solve for L if I divide by root 3. And there's a root 3 ready and waiting on both sides of that equation. So that means L equals 6. Now that we know L, we're going to plug it in everywhere we see an L, which means y just equals 6, and x is equal to 2 times 6, which we'll simplify and write as 12. Number 4, we have a 30-degree angle again, so we're going to fill in a 60-degree angle up top. The shortest side is across from 30, equal to L. Longest side is across from 90, equal to 2L. Final side will be equal to L root 3. We don't know our L again, but we do have an equation we can solve. I don't know if I can squeeze this in. We'll try to write it small. Divide both sides by 2, and that means that 3 halves is equal to L. Now, 3 halves is officially 1.5. That is an exact answer, but typically we leave our answers for these in fraction form. Once we know our L, even if it's a fraction, we're going to plug it in everywhere we see an L. So over on this side, 3 halves equals y, and that's all there is to that. Down here, x equals 3 halves with a root 3 attached. Typically, the best thing to do is to take that root 3 and to write it in the numerator. So you'll typically see your answers written as 3 root 3 all over 2 when you have a fraction for your L value. All right, go ahead and flip the page and meet me back here for some more examples. Moving ahead to example 5, we're just going to keep doing the same thing. I see my 30-degree angle, so across from there is my shortest leg. Across from the 90 will be equal to 2L, and then across from the 60, if you need to fill it in, will be your L root 3. This problem tells me what L is equal to, so I'm ready for the step where I take that 5 root 3 and I plug it in everywhere there's an L. For u, that looks like 2 times 5 root 3. I can simplify those two numbers that are coefficients, and u will be equal to 10 root 3. For v, be careful here, L is equal to 5 root 3, and then there's a root 3 next to that before you get to the equals v. These roots should combine. If you want to write it as 5 root 9, you certainly can, but the square root of 9 is actually 3. So the best answer you can give that's exact and simplified would be 15 is equal to v. 6 is going to be really similar. Your shortest leg across from the 30 is 5 root 2 this time. That's going to be equal to L. Finish setting up your labels. So across from 90 is 2L, and then our last side, which is across from the 60, is going to be L root 3. If 5 root 2 is equal to L, that's going to replace all of the L's around this triangle. U will be equal to 2 times 5 root 2. And just like the last time, those coefficients multiply together to give you a simplified answer for U. I'm going to drop this down here just so there's a little bit more space to see my work. L is 5 root 2 multiply that by root 3 so that it can equal v. Root 2 times root 3 is 5 root 6. This root needs to be simplified if possible. So if you do a quick think through factor tree maybe this time, 3 times 2, those factors don't match. So that means this is actually already simplified, but it's worth checking to see if you can simplify anytime the root turns out to be bigger than what the problem gave you at the beginning. All right, number 7, I see a 60 and a 90. So this corner here is going to have 30-degree angle measure. That means that this side is my shortest and equal to L. Across from 90 is going to be the longest, equal to 2L, and then across from 60 will be equal to L times root 3. Since we already know the L, all we have to do is plug it in. So we're going to do 2 times 5 halves to figure out our x. That's really equal to 5. Up top, we're going to have y equal to 5 halves times root 3, but remember when a fraction has a root 3 multiplied, the best thing to do is to write the root in the top of the fraction. So 5 root 3 over 2 will be your y value. One more in this top row. I see a 60 and a 90, so this top corner is 30, which means across from that 30 will be equal to L, the shortest leg. Across from the 90 will be equal to 2L, and then across from the 60, my last side, will be equal to L root 3. We don't have the L this time, but we can find it quickly by dividing both sides by 2 in this little equation, which means L will be 8 for this problem. Taking that 8 and plugging it in, y equals 8, and x equals 8 root 3. If you're feeling pretty good about these, you might want to stop the video, pause it, and go ahead and try the next row on your own, then come back and check your answers. Otherwise, if you need to keep watching the examples, we're going to continue on with number 9. We've got a 60 and a 90, so this corner will be 30 degrees, which means across from that 30 will be our shortest side. Across from 90 will be equal to 2L, and then our third and final side will be equal to L root 3. To solve for L this time, we're going to do 9 divided by 2, but because that's a decimal, I'm going to leave that in fraction form, and we're going to plug that in for each L. Y will just equal 9 halves. And then here, remember when we multiply that by root 3, the best thing to do is to write that root 3 in the numerator with the 9. So x is equal to 9 root 3 over 2. Number 10, we've got our 30-degree angle already on the picture, so across from there will be our shortest side. Across from the 90 will be 2L, and then across from that 60, if you need to fill it in, the third and final side will be equal to L root 3. We've got a little equation here we can solve. I'm just going to write it a little bit down farther so that we've got enough space to see the division happen. That's going to isolate the L, and because we have an 8 available to divide by 2, we'll simplify that to get 4 root 3 as our L. Take that back and plug it in to find your M and your N. For N, it's just going to be 4 root 3 equals N. Nice and easy there. For M, we're going to have our L, which is 4 root 3, but then there's an additional root 3 that multiplies on that. Remember, these roots combine together to be 4, not M, sorry about that, root 9. Root 9 is really the same thing as 3 if we simplify it. And so our final simplified answer for M will be 12, 4 times 3. So sometimes there's a little bit of effort once you plug your L in, making sure you get to a simplified answer. Make sure you work through that process. Your answers won't be right unless they're simplified. Number 11 kicks it off with a 60 and a 90, so our 30-degree angle is over here, which means our shortest side equal to L will be the y. Across from 90 is going to be equal to 2L, and then across from 60 will be equal to L root 3. Here's our equation that we can use to help us track down our L value. Things work nicely here on both sides, and L is equal to 9. Taking that and plugging it in, that means that Y is equal to 9, and up top we would do 2 times 9, which means X is equal to 18. All right, last one on this page. We've got our 30, which means across from there will be our shortest side equal to L. Across from the 90 will be equal to 2L. And then across from the 60, that third side will be equal to L root 3. This one's going to be very similar to number 11. To figure out our L, we need to divide both sides by root 3, which means L equals 6. We take that 6 and we plug it in anywhere we see an L. Y equals 6, and X equals 2 times 6, or 12. All right, go ahead and flip the page. I'll meet you back here for some examples that are a little bit trickier. Again, if you're feeling good about things, feel free to try them, pause the video, and then come back and check. Otherwise, we'll be back to work through them together. All right, picking back up with question number 13, we're going to start, like we always do, by finding that 30-degree angle and traveling across to identify our shortest side, our hypotenuse equal to 2 times L, and then our third side equal to L root 3. Divide both of these by root 3 to figure out your L is equal to 2, and then plug it in everywhere you see an L. Y is equal to 2, X is equal to 2 times 2, so X is equal to 4. We've got a 30-degree angle at the top of the next one as well, so our shortest leg is still that bottom side. Our hypotenuse is still across from the 90, and across from the 60 will be L root 3. We still need to find L, so we're going to divide by root 3. This time, we need to simplify this division problem. Root 6 divided by root 3 is root 2. So our L still has a root attached to it. We take that whole value for L and we plug it in, and Y equals 4 root 2. Up top, I'm going to move this down just so we can see it a little bit better. We're going to have 2 times the L of 4 root 2 to figure out our X. These two coefficients combine together, so our answer for X will be 8 root 2 once we simplify. Number 15, our 30-degree angle is right there on the right side, so across from there will be equal to L. Across from 90 is our hypotenuse, equal to 2L, and across from 60 is our side that's equal to L root 3. This is going to be a problem. When we divide to figure out our L, we don't have a root available to simplify. So this is what we practiced at the beginning. Remember, there's 2 methods. You can either multiply by a fraction to simplify that way, or you can decide not to divide and multiply instead. So I'm going to show it this way first, and then the next time we run into one of these problems, I'll show it the other way. Because I have a root 3 stuck in the bottom of this fraction, I'm going to make another fraction next door that has a root 3 in the numerator and the denominator. So as I simplify this, I'm multiplying straight across, those numerators combine, and then straight across the denominators combine. Root 3 times root 3 is root 9, which then simplifies to be 3. And for this problem, 3 divided by 3 then simplifies to be 1. So L is really just 1 root 3, which we can write as root 3. Now that we know it, we plug it in everywhere the L goes, just like always. So root 3 equals Y. Up top, X is 2 times root 3. Neither of those can be simplified anymore. I think the same issue is going to pop up here in number 16. So if this method here doesn't make sense, go ahead and watch through this one and see if you like this approach a little bit better. Across from the 30 is the shortest leg equal to L. Across from 90 is going to be 2L. Across from 60 is going to equal L root 3. And sure enough, I'm going to have to divide to get rid of that root 3. But I can see 45 divided by root 3 is going to be a problem. So if you don't want to divide and simplify like we did over here for number 15, the alternative is that you actually multiply both sides by root 3. So this is an extra root 3, and this is an extra root 3 compared to that equation up above. What that does is it moves the radical over to the other side of the equation, and it creates a regular 3 on this side that we can then try to divide by instead of the root. 45 divided by 3 is 15. So our L turns out to be 15 root 3, and then we just use it like we always do. Plug it in for all of the L's. So up top, we're going to have 2 times 15 root 3 equal to M, or 30 root 3 as a simplified answer for M. And then for N, it's just equal to L. So N is 15 root 3, our L value. All right, number 17. Number 17, we're missing our 30-degree angle, so I'm going to fill that in the missing corner. Across from there is our shortest leg. Across from the 90 will be equal to 2L, and then our final side will be equal to L root 3. So we're going to have another chance to practice whichever method you like for solving when the root gets stuck in the denominator. We've got L root 3 equal to 9, so we're going to need to divide by root 3. I'm going to go back to the first method, which is multiplying by a fraction that has that root in both the top and the bottom. Over here, L is by itself. In the numerator, we're going to have 9 root 3. In the denominator, we have root 9, which simplifies to be 3. So then a quick check, 9 divided by 3 is possible. So we're going to simplify that and end up with an L equal to 3 root 3. Take that, plug it in for all of your L's. That means X is equal to 2 times 3 root 3, which is 6 root 3. And Y is just equal to L. So Y is just equal to 3 root 3. Number 18, our 30-degree angle goes there in that empty angle spot. So over here, N is equal to L. 18 is across from 90, so it will equal 2L. M is our third and final side across from 60, so it equals L root 3. Solving this equation, you can probably do in your head. 9 is going to be our L value. So then we take that L and we plug it in. That means 9 equals N, and M is equal to 9 root 3. The last two on this page already have the 30-degree angles available to us. So across from there will be the L. Across from 90 is equal to 2L. Across from that last empty corner, which would be a 60 if we filled it in, will be equal to L root 3. We already have our L, so we're going to plug 10 root 3 in everywhere we see an L. 10 root 3 times root 3 equals N. That's really 10 times 3 if we simplify, which means N is equal to 30. M will be 2 times 10 root 3, which if we simplify by multiplying those coefficients together means that M is going to be 20 root 3. Last one, shortest side is across from 30, that's equal to L. Across from the 90 is the hypotenuse, that's equal to 2L. And then our third and final side equals L root 3. We've got the ability to find our L this time by dividing both sides by 2. That means that L is going to be 8 divided by 2, which is 4 root 6. Taking that and plugging it in up top means that Y is equal to 4 root 6. Plugging it in here means we have 4 root 6 root 3 equals X. Root 6 times root 3 is really root 18. We had one of these earlier where we had a root that's ended up being bigger than what we started with, and we said we needed to try to simplify when that happens. So if we do a quick factor tree or factor table, 18 might be able to be split up as 2 and 9, which would then be 3 and 3. So sure enough, it looks like we've got a pair of matching factors. So this becomes a 3 root 2, but remember, that's just the root 18 part. So this 4 also needs to follow us down and be multiplied by that result to represent our X. So the official simplified final answer for X should be 12 root 2 when we get through that whole process. All right. This lesson does have a part 3. Part 3 is review. It mixes both the 45, 45, 90 and 30, 60, 90 triangles together. So that will be recorded in a separate video in case you want to practice that first, which is probably a good idea. So this is the end of the 30, 60, 90 part. Thanks for watching. Hopefully that helps.